Hey, good morning, everybody. Welcome to today's webinar, part of our Modernize Your Wireless Network series. I'm here with Eric Marski today, who's our resident expert on doing all things wireless. So what we're going to do is something a little bit different today in that we've kind of gone through a part of this series, and we'll kind of get into this a little bit more of how do we modernize, or when people are modernizing their communications, what goes into that and matching up your wireless networks. And so we've kind of gotten partway through this now, and what we're going to do today is we're going to kind of get into maybe some of the questions that came up that maybe we can give a little bit better explanation to, a little bit more of a fireside chat, if you will, kind of a different take. So just to kind of I guess, catch everybody up of where we've been going with this. When we're looking at this digital transformation, something that's going on all around us, in which we've kind of gone from this industry 1.0, way back when, we've kind of now gotten into this industry 4.0. And really what this is we've had this transformation, which we're moving from a serial-based communication scheme into an Ethernet-based system. And so not only are we changing the physical connection and the type of data, but the whole premise or the whole idea of this communication schemes has changed. So the serial days, we're really kind of dealing on a device-to-device level communication. As we've moved now into the Ethernet, not only have we changed the structure and everything else that way, but the idea is that now that we can network this. Okay, so everything is going to be connected. There's different, we've got digital transformation, the connected enterprise. There's different names for this as we go through that. But really when we start looking at it on this kind of this new model that we have, is we've got kind of out here, this image will show you, is we've got things out in the field, devices. These are your PLCs, your cameras, your IoT devices. And what we're trying to do is to get it to the far right side there, in which we can take that data and actually do something with it. We can analyze it, we can make actionable decisions based upon that data that we have and have an abundance of. What we need now is connectivity. We've got to be able to get the things to be able to talk to that, to basically to analyze this. And then we've got to have somewhere to store that data. And so it's kind of what today's model looks like. And so really what we're looking for in this connected model is we really have to have 7 things. We've got to have reliability. We've got to have a persistent data acquisition. We need edge-to-edge cybersecurity. It needs to be able to support both layer 2 and layer 3 connection types. That network can actually keep the data on premise. Sometimes we want to be in the cloud. Sometimes it's a hybrid. We want to have both of those. It's got to be scalable and very cost effective, so that not only is it going to meet today's needs, but also as we look into the future, is it going to be able to keep up with that? And then honestly, the days of the IT and OT silos is gone. We've got to basically have a frictionless, and it's got to basically coexist between these two departments, the OT and the IT side of things. So when we kind of look at this, making this leap to get these things, when we start bringing now wireless into it, it's a pretty big leap. And so we've got to not only modernize the network, but now we also have to modernize that wireless network in order to achieve these things. That's kind of really what this whole series has been about. And when we talk about modernizing your wireless network, really what you're kind of looking at is kind of 2 sides to this. And we kind of feed this through. We want to look at the what of it. And this is really where we've concentrated up to date on this webinar series, is the, what's going on? Is this serial? Is it Ethernet? Is it something we're transitioning from serial to Ethernet? Can we make it more reliable? Can we make this into something that can heal itself, or be something a little bit more, I guess, reliable is probably the best word, dynamic, in which this can react to what's going on within this. It's got to be secure. How big of a deal is that? Are we dealing with roaming and mobile applications? Is it vehicles? Is it AGVs? Not everything is stationary anymore within this industrial automation arena. Do we want to include Wi-Fi clients? That's another big thing, and this can be thin clients, it can be thin managers, it can be your IoT sensors. There's a lot that goes into this under the kind of the guise of Wi-Fi. And then also we want something that can be very rapidly deployed. That's one of the beauties of wireless, is this can be up and going in a matter of, we'll call it hours, rather than days, months, weeks, whatever, when we start dealing with having to go through and trench or lay wire. Then we really have to kind of look at the physical or the where of this. And this is going to include things like distance and terrain and the physical environment itself. What we want to do is to consider both of those, and that's going to drive us to kind of the best frequency, the best technology that's going to actually make this a good, stable network. And so what we've done is not only this webinar series, but also up on the website, we've actually dedicated a whole section to this to help guide you through this. And so this can be accessed directly off of that page, but really what you're looking at is we address each of these areas in its own section. And so you can see in each one of these blocks, if you hover over it, we'll flip and allow you to dive a little bit deeper into it. When we start getting these questions, and this is really driven from the customers and the integrators and the distributors, is I've got a customer or I'm trying to do X. And there's different reasons on this thing. You know, some of it is because they're moving to Ethernet. Some people are already there, but they need to increase their security. So there's different reasons for doing this modernization. And that's really kind of how we've approached this is this is what people are coming to us with on how to do it. So we want to share this information with you. And we kind of get into the other side of that is the where of it. And it's kind of done in the same way as here's the considerations for distance or terrain or the environment itself. Okay, so what we did is we put together this series for modernizing the wireless network, and this is kind of the dates, and this is something you can actually download right out of down into the notes section there. And really where we're at in this journey now is really answering your questions, this tech talk, if you will. And so that's really kind of what we're going to do for the rest of this webinar is these are the questions that have been posed to us. And if you've got more questions as we're going through this, feel free to open up and fire them away. We're watching that as well. Because again, this is things that have cropped up, says, okay, I get what you're saying, but let's expand on that a little bit. Okay. And so that's what we're looking at today. So it can be a little different than most of the webinars that we've done. Rather than just us talking through a bunch of slides, we're getting a little bit more interactive. We're going to put Eric on the spot a little bit. And so really kind of the first one that we get into on this, and I'm going to kind of take notes as we go along with this so that we can document this a little bit. Really the first one comes up is on security itself. And so security is in itself kind of at the forefront today of almost all these conversations, you know, is we've got, you know, different remote access, we've got vulnerabilities. So talk a little bit more about on security and how do we handle, or how does ESTeem look at security?
Okay, that's great. This is a great place to start, honestly, is the first thing we need to understand about security. And we've actually we've kind of really gone well into security on some of these other talks that we've gone through. But kind of wrapping all this up, we need to understand the biggest thing about security is it's a multi-level system. No one piece of security actually solves all problems. And the biggest problem that we run into is that security and simple encryption often get, you know, replaced for each other. We need to understand that going beyond just simple encryption or making the data difficult to understand really fits the overall security model. What we're doing by that is most people kind of understand that we need to get past just the first thing is once we are actually encrypting the data, okay, we can actually encrypt the data quite heavily. We can actually go all the way up to AES 256. Okay. Just as kind of a comparison for that, most of the internet transactions are running at AES 128. So we have actually superseded that on the wireless because we want to make the radio as secure as we possibly can.
Sure.
So now that we've got this first layer, what else can we possibly do? What else can we add to that to enhance that security model? Well, we've gone and actually done quite a bit just in the radio alone. We're talking not outside of network security. This is just actually in the radio itself. So a few of the things that we can do with that can actually greatly help with security is we have the ability within any one of our radios. It doesn't necessarily have to be specifically those that are in the Wi-Fi arena, the 2.4, the 5.8 gigahertz band. We can actually adjust the bandwidth. Now that may seem like a trivial change, but what that does, it's unique enough to the fact that even if you had a system that's operating in those, you know, open protocol standards, if you adjust the bandwidth to something that the device doesn't understand, It's a great security enhancement. We don't necessarily need to run that. We can run on any bandwidth model, but it does allow us to actually increase the level of security to it. We also have the ability to go in and authenticate the users. We can do that in many different methods. We can do it in a standard security method to where you're actually just inputting the security mechanism, or we can actually go all the way up to, say, the enterprise model, to where we're actually having a separate server that's doing nothing but authenticating users coming in and out of that network. We've actually got abilities within the radio to do things like what we call an access control list. Now, this may seem like a simple thing to do, but it is actually incredibly difficult to break, where you're specifically telling the radios what devices are going to allow to enter that wireless network. So we can actually then drive down exactly what group of addresses or what devices can enter that wireless network, even if they had the correct permissions to it.
Is that something we have to do, or is that something that can be done on the fly?
It's actually something that we do as part of the configuration for the radios themselves. What we're looking at as far as the some of the unique features we're adding into it now is to kind of meet our modern specifications. We actually have the ability to have unique passwords. The way they come out of the factory, no two radios are the same. It allows you to get in and adjust it. You can adjust the administration password within the radios themselves.
Okay.
We also have the ability to actually, we have several different tools available to us where we can find the radio in the network or configure the network over a large graphical interface. We also have the ability to adjust those tools so that if you want to lock it down to where you don't have the ability, you can read the information off of the network, but can't adjust it through those tools. You can actually adjust that in any one of those radios.
Okay.
What we want to do is we kind of want people to understand that you're setting the level of security as the user. You define in there what the security model is for your network, and you can adjust it based upon this. Again, we can look at different, say, frequency bands as an alternate for security, where you can actually, you don't necessarily have to rely on what are known frequency bands in the network. We make several different radios, and we actually cover different frequency bands that are outside of that Wi-Fi band itself. So it gives us the ability to not only adjust the frequencies that we're operating on, but there are actually several modes of operation. We'll get into that here in a bit, but what we're seeing is that we have the ability to not necessarily just pass information directly between clients and the master or between fixed locations. We can actually go in there and adjust them to use, say, a router mode or a firewall mode that we classify that as kind of a masquerade, where we're defining all of these network entities into a single IP address on a network. So a combination of these different elements really give us the ability to create a larger security model. Overall, what the easiest thing to understand out of this is the fact that you have the ability within these ESTeem networks to define exactly how much and what level of security you want them to operate on. Is the best thing to take away from.
Okay. And I guess the only thing that I'd really add to that is also as security is always changing.
Yeah.
And so I think one of the things also we wanted to stress is as in a couple of years down the road, 2, 3, 4, 5 years, there may be something else, another version of an AES or whatever that happens to be.
Sure.
I think the other thing to make sure we tell on the customers is that would be available to their current product as well, just through a firmware update. Okay. So we're constantly keeping up with the I guess the most leading edge on the security side, but that doesn't mean that if you buy today, that's where you're stuck.
Good point. Very good point.
Good.
All right.
Well, we'll move on then.
All right.
So as we kind of look at another question that popped in is, and this is not only through the series, but that we get a lot of times. When we talk about the Horizon 900, and this is really the question is how does ESTeem achieve 72 megabits when everyone else's 900 is only around a 1 megabit? It's a good question. It's something that comes up all the time. So can you maybe enlighten us a little bit without getting too techy with us, and how do we pull this off when other people aren't?
Okay. I'm glad you brought it up, because quite honestly, the Horizon 900, it is a unique, unique entity, especially in the wireless world. What we've actually done is most of the 900 megahertz radios that have been classically on the market, and what really is kind of a limiting factor as far as their speed is the type of modulation they use. We'll get delve too deep into exactly how each of these works, but most of these are operating on what's called a frequency hopping model. Okay. So where you're taking the data and basically you slice up the data and send each piece of it on a different portion of the bandwidth you're operating on. It's great for security. The only problem is because you have to serially put that data in a specific order, your throughput on it is kind of really capped around that 1 to 2 megabits of throughput. Well, realizing that, there are other customers that use that, because quite honestly, we have a radio that does that kind of transactions. We wanted to be able to go, we want to be able to enhance that. The way that we have done this is we actually utilize the same modulation method that is used in Wi-Fi. We actually use what's called an OFDM modulation, or orthogonal frequency division multiplexing. You can impress all your friends with that. Really what this comes down to is that we utilize the same methodology that the higher throughput radios do, but in that 900 megahertz spectrum. Now, what makes that a little bit unique is we don't necessarily have to be tied to a specific bandwidth again. We have the ability within that radio to adjust how much bandwidth we have across that band.
So that would also bring in the little bit different, I guess, architectures as well.
Correct.
And gets into more of a mesh instead of a master-client relationship.
Yeah. Because
of that. So does it take better line of sight? Does it require more signal? Does it take more horsepower to pull this off?
I guess the best way to look at this, when we're talking, especially in a modernization, when we're moving from one radio system to the next, if we're moving into a radio, say the Horizon 900, it does actually take more signal to get between those two remotes. And that's more or less a function of the modulation itself. It's really not necessarily tied to a model radio that we manufacture. It's just that the modulation itself, because what you're doing is you're actually moving that data across a very wide bandwidth and transitioning or sending them all at the same time.
Takes more power.
It takes more power, and it actually takes more signal to be able to do that reliably. Okay. So one thing to consider when moving into or looking at a system that can do this is that, do we have the signal strength available to us to be able to do that? In other words, we don't want to take a network that was barely operating on the frequency hopping model and hoping that this Horizon 900 would actually work in there. Okay, we have to be able to consider that and make plans to make sure that we maybe add in a repeater, maybe change things around, change antenna types to it. There's many different ways that we can do that, and we'll be more than happy to help people make that transition into this radio. It is so unique for the fact that now you can still maintain the great throughput, the great terrain modeling that you get out of the 900 megahertz, but you aren't now capped to a very, very low bandwidth. Okay. We're able to bring that 900 megahertz to a whole new audience, really, is what we're doing.
That probably adds to the security as well, being on a non-Wi-Fi band.
Very much so, very much so.
It kind of dovetails into another thing as we're talking about achieving these high data rates that comes up often. So using the Horizon 900 and the 72 megabits, is that throughput, is that data rate, are they the same? This is something, am I going to get 72 megabits of data going through this thing, or how do those two work together?
That's a great way to look at it. Really what the data rate is how quickly the radios pass information from one to the next. There's a lot of things that go on inside of a radio that we need to, essentially compensate for, let's say. We've got to turn the radio on. We've got to demodulate the data. We're securing it. We're running these, high-level encryption models over the top. So a very simple rule of thumb, and quite honestly, you can apply it to any radio system, is when we're talking about throughput, in other words, moving data from point A to point B, as if you're running it through a switch or something like this on Ethernet, a side-by-side comparison is about 2 for 1. So our 72 megabit connection running in the Horizon 900 will get you approximately that 35 megabits of throughput as a side-by-side comparison.
Okay, so about half.
About half. It's a 2-to-1 ratio.
Okay, fair enough. Okay, we'll keep moving because we've got only so much time here. Kind of next question is that we get is what's included with an ESTeem radio? So if I order up a Horizon 900, what am I getting?
Oh, good question. Quite honestly, what we're doing is because each one of the applications that we're putting into it is actually unique, okay? So the bill of material for each one of them is going to be different, whether it be a point-to-point, a point-to-multi-point, what environment, how far the antenna is. We don't have a canned set, kit that goes with the radio. We kind of sell it a la carte. So the reason we do this is when you're purchasing the radio, you're going to get the radio, the connection and the power. You're going to get all the software that it takes to run that, all the tools and everything that come with it, but all the other accessories that are required in a radio communication system: the antenna, the cable, the lightning suppression, the power supply, everything like this. We tailor those to the application that it goes into. Now, we're more than happy, because that's one of the main things that we do, is we discuss these things with the customer when they're calling in and talking to us to find out what environment are they putting it into, what areas do we need to get around. There is just no one simple cookie cutter that goes for all of those. So the one thing that we do have, though, is we have accessories for all those different scenarios. Whether we're doing a remotely mounted antenna, whether we're putting an antenna right onto the radio, these are the things that we do.
Okay, so if we take that and apply that, so antennas, so there's a lot of different options out there. How do you decide which one to use? So if I'm picking one for this application, okay, is it based on color?
Right.
How do we know?
That's a great way to look at it. Quite honestly, there are a lot of variables that go into picking out or basically designing this radio system. Okay, we try to make this as simple as we possibly can. Really, antennas fall into two broad categories: either antennas that are going to communicate to multiple stations, okay, or ones that are going to communicate to a single point. So we then can come back to our model again. Where is it going? So if you've got a site that's talking to, say, a master site, it's going to need to communicate out to multiple. So it's going to need a different antenna type than those that are communicating singly to the master.
Yep.
Okay. Same thing for repeaters. Repeaters pass that information on to multiple sites. So they're going to need a different antenna type. But we're not going to leave you hanging on this, okay? We've already basically consolidated all this information, not only into the training classes and things that we offer, but we also offer that inside of the RF design program, okay? The RF design program is free to download from our website. And what it will do is it will tell you, based upon a math model, what you're expected to get out of the equipment that you've selected for your application. If you're finding that you're not getting the throughputs and data rates that you expect or need for that application, that tool will greatly help you adjust that without having to purchase the hardware, install it, find out it's not working, and then change it. That's really one of the key benefits of that program. And again, we offer this to people. We utilize it ourselves all the time. Okay. If you are stuck for all this, this is something that you've never really dealt with before, you're not comfortable with RF, we do still have engineering services available to where we can come out, help you design this system, help you commission the network, whatever level of turnkey service you need from us, we have it available.
Gotcha. Okay. Good. Yeah. So it's not just winging it then.
Exactly. We're not going to leave it out for you to figure out.
So another one is as we're talking about modernization, and we're talking about we have a lot of customers that are saying, okay, I've got this today, but it's not cutting it. I need to move into this. Can they, I guess the question is can I use my existing hardware if I do this modernization?
A quick answer for that is maybe.
Okay.
The reason for that is because the hardware really in a radio system is frequency dependent. So you can't say move from a 2.4 gigahertz system to a 5.8 gigahertz system and keep the existing hardware. The antennas, the cables, most of the things are actually kind of tuned for a specific frequency band.
Okay, that makes sense.
So if you're staying in the same frequency band, there is a good chance that you can reutilize that same hardware as long as you're really maintaining the hardware as it goes up. We generally recommend, verification or tests on all radio systems in a yearly preventive maintenance plan, to where you're actually going out and verifying that there is no losses in the cable or antenna. And you'll utilize this as you go through there and keep your system up and running. If you've got sites that are having problems, putting a new radio system into that kind of network is not going to fix it. Okay, this then some of those accessories may need to be replaced. Generally, we've seen over time, outdoors, you can expect about a good 10-year life on your antennas, cables, and things like that. And of course, it really depends on a lot of different factors, how much humidity there is, where it's actually located. Each one of these are. So it's one of those things, as long as you can stay on that preventive maintenance, there's absolutely no reason you could not keep your existing hardware.
So kind of keeping with that same theme of modernization, and a lot of this stuff, cables, antennas, lightning arresters, I mean, this is not new stuff. This has been around forever.
Sure, absolutely.
So if we kind of look at this in terms of modernization, is there a better way of mounting these things now? Has that improved? Is it better cables? Has that kept up with the technology?
Well, we have actually adopted into a lot of these newer standards too, because as you mentioned, these cables, we've been making radio systems as a whole the same way since the inception of radio, quite honestly.
Okay.
So what we've done is we've kind of taken a little bit different approach to it. What we've actually have modeled in front of us is actually how we're doing a lot of the modern mountings now. So we're actually mounting the radio itself either directly to the antenna or at a very, very short distance away from that. Well, what you're getting out of this is you're getting several different advantages to that. Some of the biggest advantage to it is that most of the signal loss inside of a radio system comes inside of that coax cable.
Okay.
Because what we're doing is we're moving energy from the devices actually making the energy into an element that's tuned specifically to get it airborne. Okay. So anything that goes in between those 2 points is actually going to have a certain amount of loss.
Okay.
So we're minimizing that. So we're able to put out more power into the air. Well, as we talked about earlier, do we need more signal? Well, the more signal we have, essentially the faster the radio can go. So we're actually able to improve the system as a whole by utilizing a mounting system like this.
It's a better performance as well.
Absolutely, absolutely. And we're also eliminating a lot of the pieces to it, because quite honestly, everything within the radio system outside of actually getting it power is resident actually on the outside area. So we actually have to use what we have a system called the pole mounting kit. And what this does is this basically gives you all the hardware necessary to make this radio NEMA 4 rated or be able to mount outdoors reliably. Okay. The only cable that runs to it is a simple outdoor rated Ethernet cable. We're looking for a shielded cable there because we actually run our lightning suppression system within the cable itself. We're actually on the skin of the cable itself. So the installation becomes very simple. We run one single Ethernet cable to that radio. You can mount it where necessary, or even say in areas that require intrinsic safety. We can actually run the radio and antenna system completely out of that. And the only thing that runs to it is a simple Cat5 cable.
Okay. So we've got a new way of mounting this. Does it have to be mounted that way?
Absolutely.
I mean, do we have to mount this up on a pole, or can I stick this into my cabinet, my enclosure that I've already got?
Yeah, if you're, like we've talked about, if you already have the radio system configured for that type of a system, there's no reason you can't utilize it that way. We just provide this as an additional feature to our radio.
Just an option.
It gives an option to be mounted outdoors. In a lot of cases, it can greatly simplify installation, and especially when designing a new radio system, you can utilize all these advantages to it. But if the system does require that we remotely mount the radio, there's absolutely no reason we can't do that.
Okay, good. All right, well, we'll move along then. So let's get past the nuts and bolts of the radios. Are these radios or these new modern networks, are they going to support these new protocols? Ethernet IP or Modbus TCP?
Sure.
Some of these things that, where do we draw the line? Can it support these new modern protocols or what people are modernizing to?
Sure. Well, the easy answer is yes. And the reason that we can say this is the fact that, quite honestly, we're just replacing some of the lowest levels, basically the physical layer and the MAC layer in that Ethernet stack. And what that really does is we're essentially replacing the cable. We are absolutely agnostic to the type of protocol that runs over the top of the radio itself. We're not tied to a specific protocol type. We can run any type over the top. We're essentially transparent. We don't necessarily, now we can interact with some of these, and quite honestly, what needs to be considered more than anything else is not so much the protocol, what runs over the top, but what are the requirements for that protocol? Because a lot of the new modern protocol standards that are out there have very, very tight timing sequences and things like this. Okay. So when we're looking at modernizing or moving to these new standards, we need to make sure that the hardware and the system that we're putting in is going to be able to meet those requirements or have the ability to adjust the timing requirements within those protocols to allow us to run over wireless. Now, wireless is getting close to running the same speeds that a hardwired system does, but overall it doesn't. There's a certain amount of latency to it. So we need to make sure that when we are applying this to a new application, that we make these considerations at putting it into the system.
Okay, so it's not so much the protocol, but what the requirements of that protocol are from a latency standpoint.
Absolutely, absolutely.
Okay. We'll keep moving because we've got we're getting down on time here. So now you've talked a little bit about modes of operation. You're talking about a router mode and masquerade mode and just kind of a standard bridge mode. Which one do I use? I mean, that's a question that we get all the time is there's all these different modes out here. How do I pick one? What should I be using?
Right. And not to keep utilizing this, coming back to the same answer, but really it depends upon the application itself. What do we want the radios to serve? Or what do we want the radios to solve within this network? We actually do have 4 broad categories of modes of operation. One we'll call the bridge mode, where essentially the radios look like a piece of wire. They're completely transparent. Whatever happens at one side gets transferred to the other. In a lot of cases, that's a vast majority of the applications we do, because that's what you want the radios to do, is you want them to disappear within this network. We also have the ability within this radio to support a router mode, to where if we need to isolate the devices beyond the radio, we can only then send specific traffic to those devices. So we don't have to carry forward all of the Ethernet traffic that goes inside of, say, a building network. We don't have to transport that across. And it's kind of an additional element to that, a router mode. We have the ability to do a firewall. In other words, we can isolate the 2 networks completely from each other. One can gather information from the network, but it can never push the other direction. Okay. And we do this in a mode called masquerade mode, to where really the devices beyond the radio are going to look like a single IP address on the network. Much like the way a home router works, is very similar to a masquerade mode. Now, we're not necessarily limited to just those. Now, we have all of these different abilities we can actually do within the radio. We can make them look like a mobile device. We can actually have the radio appear in several different station modes. Again, what we're trying to do is make sure that the radio has the ability, depending upon the application that's going into, is it going to be able to solve that? Those are really the key elements to which modes we need them to
do. So that you mentioned that we can kind of set this up, same thing that we do in a home Wi-Fi system. So my home Wi-Fi system, I have a guest account and my own account. Is that something that ESTeem can do as well? Can we set up? Can we isolate the maybe different users from each other?
That's a fantastic question. Quite honestly, yes. And we're doing it in a little bit more enhanced way. What we're doing is that we're doing something called a twin bridge. Okay. Where essentially you have the ability to not only set up different networks by different names, so you may have different clients connecting into it, but there is actually an air gap between those 2 networks. So you can actually have a system that can provide, say, client access into the building, but that same radio can be tied into the control system completely separate Ethernet inputs into the radio. Sharing, the only thing that's sharing is that radio transceiver itself, but the networks themselves are completely independent of each
So you
other.
could run two different networks across the same set of hardware.
Absolutely, absolutely.
Interesting. Okay. Because so when the other one is, so we talked about this mobile, we're going to go into this.
Mhm.
Does the ESTeem products, do they support this fast roaming, that terminology that's out there? If I'm in a mobile environment, is this something that's going to be, moving it like at slow speeds? Is this something that I can do driving down in a car? What kind of speed are we roaming this at?
Okay, well, that's great, because quite honestly, the term fast roaming, that's actually a proprietary terminology. We handle roaming a little bit different. The one thing to understand is that in a client application, anything that has to do with Wi-Fi based networks, okay, the client themselves actually make these decisions. They're the ones that are looking at what's available to them, what networks are out there, and realizing that we're putting this out into large, could be city, county-wide networks now, okay? We have to be able to then create within that radio. We essentially have a custom roaming code within the radio, okay? What we do is we base it upon the amount of signal that the radio receives.
Okay.
So if it's receiving we'll call a threshold value, in other words, as long as it's receiving the signal that it's happy with, it will stay with that network. But you also have the ability to adjust that so that if the radio now sees a better station to talk to, it doesn't necessarily have to hold on to that first one until it completely loses it. You can actually now tell the radio to transfer over to that new network, okay? So this roaming is very, very adjustable. It's very, very, you can adjust it, set up specifically for the application it goes into. So good application example of this is if we're utilizing, and we've used these radios a lot with automatically guided vehicles or AGVs. And those are generally in a smaller space, but there's a lot of them within the network. So we don't want them all to tie to a single access point if that one base radio can't support that many mobile devices. So we can spread the load out across the network by putting up multiple of these. And then you define within that radio how rapidly you want them to move. In other words, we can tune it so that they're not, or how aggressive based upon the hysteresis in the radio, how quickly you want them to move between different base stations for it. Okay. So we're not limiting to just a one set value within the radio of when you want it to roam. You have the ability to adjust all of those elements.
So I guess looking at that kind of a different way is, so we're just talking about protocols and latency and things like that. So we could actually adjust this so it's always maintaining the highest data rate if we have tight controls within this.
Absolutely.
I mean, faster speeds. We can use that basically kind of backwards. Say, okay, I'm going to maintain the highest speed possible, not necessarily because of signal, but because of the protocol considerations.
Absolutely. Absolutely.
Good. So if we get into this and we get these into a mobile mode like that, we've got questions, and this comes up anybody from, I won't say necessarily AGVs, but vehicles that are, say, roaming like this, say like a police car, fire truck, some sort of autonomous vehicle. Can they act as a repeater to get to someone else?
That is actually a new feature that we've added into our radios just very recently. The ability to actually set a specific signal threshold of when you want these radios to link. You're actually creating a very dynamic mesh system. The radios will find who they want to talk to and then allow them to pass that information from one to the next if they can't directly see each other. So they can actually function as a dynamic repeating system.
Okay.
The beautiful part is that, again, just like we've seen with everything else, it's completely configurable. You can configure it to the application. So you can set it to when you want them to enable and disable this link to the specific application. Because there's going to be greatly different settings based upon if that network is inside of a building versus whether it's going outside across an entire county. So we don't want to limit exactly how it's utilized. We actually want the ability to adjust that based upon the needs or the requirements of that application.
Okay. So kind of now moving past the protocols and some of that, it's 2022. So here's the other big question we get is, this is great. Do you have anything? Do you actually have something available? Are we talking 4 weeks out? Are we talking 84 weeks out?
Sure.
You know, and this is a question we get all the time. It's how available is this?
Well, that is the best part. Quite honestly, we own our own IP. We do all of our own design. We manufacture our radios ourselves. They're made here in the USA. Because of that, we actually have stock on all of our radios. It's not something that we don't. That's one thing that is very unique almost in this space now, that we have these radios available. They're ready to go. Just give us a call. We'll be able to get you a wireless system right out the door.
Well, that sounds fantastic. So thanks. So we're really kind of pushing up against the time and actually have run over a little bit. I say we're going to continue this journey, this modernization webinar series. We've got basically a few left, and really where we're going from here is taking it from the what and getting a little bit more into the where of it as we start off. And we do these once a month, and you can find it up on the website. But we're going to start talking about distance and terrain and environmental considerations next. So if we kind of look at that, you can see the next one coming up is going to be distance considerations. That's coming up in October, up on the 12th, and they're all at 8 a.m. So we try and capture both some that works for both the East Coast, West Coast, and anything in between. And so also these are all recorded. So if you want to go back and look at this and listen to a little bit more of what Eric just explained, try and figure out what orthogonal means, then you can actually go back and review that. But other than that, we thank you for showing up. And if you have any questions, feel free to give us a holler. Thanks, Eric.
Thank you, Dan.
All right. Thank you.